So at the end of the last video, we briefly looked at what a factorial was. And so in math, if we notice 6 times 5 times 4 times 3 times 2 times 1, we would write 6 factorial or 6 exclamation mark. Now it's really helpful when we're looking at really, really big numbers. So for instance, if I want to go 99 all the way like times 98 and all the way to 1, that'd be very, very painful. But fortunately, our calculator and our math does let us write this as 6 exclamation mark or 6 factorial. And that's the proper thing to say. Exclamation mark is just the symbol. Now, it is important to note, and this is really helpful when we want to simplify equations or expressions, that we don't necessarily have to go all the way from 99 to 1. We can actually kind of stop the factorial and just leave the remainder in factorial notation. So we have this example here. 6 factorial can actually be rewritten as 6 times 5 factorial, because 5 factorial is 5 times 4 times 3 times 2 times 1, and really 6 factorial is just a 6 in front of that yet. So this is actually saying the same thing. And I can do that with any number. Like I could pick 8 factorial, and I could say, hey, I want to go 8 times 7 times 6 factorial. That's okay. These are the same because 8 factorial is actually 8 times 7 times 6 times 5 and so on. Now that's, again, maybe in this context it's not so helpful, but again, when we want to simplify expressions, this is going to make our life way easier. Now sometimes, and not sometimes, because the diploma has conceptual questions, you're going to get like n factorial or even n plus 1 factorial and be expected to simplify that as much as possible. Well, n factorial, if we compare n factorial and 6 factorial, 6 is going down by 1 each time we're multiplying. So then with the n factorial, it's also going to go down by 1 each time. So here we have like n, and then, well, the next one should be 1 smaller, n minus 1, and then n minus 2, n minus 3. The problem, of course, is we don't actually know when this stops. And that's okay, because we're just using this generally to simplify something out. Now, if you get something like n plus 1, it's the same thing, or we can even change this to n plus 2. Well, the next one in our list of multiplication is going to be 1 smaller, so then it would be n plus 1. And the next one would be even smaller yet by 1, and so it would just be n. And then we'd get our n minus 1, and we'd end up following the same pattern. Before we look at any more word problems, I want to look at just calculating basic factorials. So we have 4 factorial. Well, that's just 4 times 3 times 2 times 1. So that equals 24. Okay, that's not so bad. We've done those a few times now. I believe that you can do them. 0 factorial, a little tricky. It isn't just 0. It is equal to 1. So just be aware of that. And then now we're starting to get into division. So now we have some places where we can do some simplification. So we have 7 factorial divided by 4 factorial. Now, yes, I could figure out what 7 factorial is and then figure out what 4 factorial is and just divide them. But there's a faster way. I know that 7 factorial can be rewritten as 7 times 6 times 5, and I'm going to stop there of expanding my factorial and just write it as 4 factorial. The reason is I have 4 factorial in the denominator. So now I can go and cancel these 4 factorials out. And all I'm left with is 7 times 6 times 5. Well, that's 210. Can do the same thing for the next one. I have 8 factorial divided by 7 factorial times 2. Well, I need to turn this numerator into 7 factorial. So 8 times 7 factorial, and then 7 factorial times 2. The 7 factorials cancel out. And so all I'm left with is 8 divided by 2. I don't even need a calculator for this question. 8 divided by 2 is 4. And now we go to the conceptual questions. So n factorial divided by n minus 2 factorial. So I need to get this numerator so at least one part is n minus 2 factorial. Okay, so it's going to be n and then times n minus 1 and then n minus 2 factorial because it's getting smaller by 1 each time. The denominator is still n minus 2 factorial. But now we can cancel those n minus 2 factorials out. And so I'm just left with n times n minus 1. You could expand this. It's in factored form. Unless it tells you which form it wants, this is perfectly acceptable. We have 1 last 1, so n plus 1 factorial over n minus 1 factorial. Again, we need to make that numerator and denominator have the same factorial, so we can do some canceling. So it's going to be n plus 1, and then times, well, take 1 off of that, so we get n, and then take another 1 off, so we get n minus 1 factorial. Well, now it matches the numerator, so I can cancel out my n minus 1 factorials. And so we're just left with n times n plus 1.